Hello dear students, good morning all of you. Welcome to Chatty Coaching classes. We are studying your 9th standard mathematics chapter, that is real numbers. In this chapter we have seen real numbers are made from rational numbers and irrational numbers. Whereas we have seen what is meant by rational numbers. Rational numbers are written in P by Q form, okay? P upon Q, whereas Q cannot be equal to 0. We have seen the properties of rational number, whereas after that we have seen the properties of irrational number. After that we have seen the decimal form of rational number. In that there are two parts we have seen. The classification is terminating type and non-terminating recurring type. In terminating type, if we divide the denominator, okay, then the remainder will be 0, 0. There will be proper division, so it is type of terminating. And non-terminating recurring type is what? In this type of decimal form, the division gets continuously goes on. Like if there is 0.333, three number is continuously takes place repeating, so we are writing it like this on itself. This is called as non-terminating recurring type of decimal form. After that we have solved your practice set 1.1. I hope you have solved all the practice set in your notebook. After that we have studied properties of irrational numbers. There are total 3 properties of irrational numbers. After that we have studied in last video lecture properties of order relation or real number. Whereas we have already seen the order relation of real numbers, okay? If you remember, in first video lecture we have seen the order relation of real numbers. Then in last video lecture we have seen properties of them. After that, square root of negative number. We all know that square root of any negative number is not a real number, because we know square root of any negative number is square root of any real number is non-negative. So square root of negative number is not a real number. We have seen all this theoretical part. Now we will move towards the practice set 2.2. In today's video lecture, I have already written the solution on the board, which will make us easy to explain you, because if I am writing on the board you can't see properly. So I have already written the solution on board. I will explain you. Write down with the explanation, otherwise take the screenshot and copy this in your notebook. Please try to revise this practice set or the extra examples so that you can get clear idea or you can solve examples quickly. See, practice set 2.2. Question first is what? Show that 4 under root of 2 is irrational number. What we have to show is 4 under root 2 is an irrational number. For the sake of that, to show 4 under root of 2 is an irrational number, what we have to do? We have to first assume that 4 under root, this is indirect type of proof, okay? You might have been seen in some theorems, like in chapter circle. You have to prove some theorems indirectly, okay? Means what? We have to assume it opposite. It is irrational number, okay? We have to show it is an irrational number. So we have to assume it like it is a rational number. So solution is, let us assume that 4 under root of 2 is a rational number. So we can find co-prime integers. If it is rational numbers, we can find its co-prime integers a and b, whereas b is not equal to 0. Okay. So such that 4 under root of 2, which is equal to a under root of a upon b. So under root of 2, 4 will go here. It is multiplication over here. It will get divided. So under root of 2 is equal to a upon 4b, whereas a and b are integers and a upon 4b is a rational number. So root 2 is a irrational number. That's how we have proved that 4 under root of 2 is an irrational number. If you want the solution, you can take the screenshot. We will move towards the next question. See, question number 2 from practice set 2.2. Question number 2 is, prove that 3 plus under root of 5 is an irrational number. Same like question number 1, we will prove this indirectly. We will give an indirect proof for this. We will assume that 3 plus root of 5, what they have said is 3 plus under root of 5 is irrational number. Okay. So what we have to do is we have to give the proof for that. We will give an indirect proof. Let us assume that 3 plus root 5 is rational number. Okay. We are giving an indirect proof. So we can find co-prime integers a and b. Okay. Whereas condition is what? B cannot be equal to 0. B is the non-zero number. Such that 3 plus under root of 5 is equal to a upon b. We have to assume root 5. So 3 will go here. It is plus 3. It will get minus. So root 5 is equal to a upon b minus 3. Since a and b are integers, we have already seen that co-prime integers a and b. So a and b are the integers and a upon b minus 3 is a rational number. Okay, this is the rational number, but it contradicts the fact that is root 5 is an irrational number. So that what we can say that the root 5 is irrational number. We already know that root 5 is the irrational number, but we are proving it indirectly. How to prove it? Let's assume that 3 plus under root of 5 is an irrational number, is the rational number. So we can find its integers. So co-prime integers are a and b, whereas b cannot be equal to 0. B is the non-zero number, such that 3 plus root 5 is equal to a upon b, whereas a and b are the integers. 3 will come here, so it will, if we will shift 3 over here, it will get minus. So 5 is equal to a upon b minus 3. We already know that a and b are the integers, whereas a upon b minus 3 is a rational number. But this contradicts the fact that is root 5 is an irrational number. Therefore, our assumption is wrong and root 5 is a irrational number. Hence we proved that is 3 plus under root of 5 is an irrational number. This is question number 2 from your practice set 2.2. If you want it, you can take screenshot. We will move towards the next example. See, question number 3 is, represent the numbers root 5 and root 10 on a number line. To represent these numbers, that is root 5 and root 10 on number line, we have to draw the perpendicular taking distance of particular 1 or 2 unit, and then we have to draw this on number line. We will skip this question for today. I will show the question by solving this into notebook. Therefore, you can understand it betterly, because to solve on notebook to solve on board, it is not possible. So we will shift towards the question number 4. Question number 3, I will solve this in notebook and then I will guide you how to solve this. Question number 4 is, write any 3 rational numbers between 2 numbers given below. They have given us total 4 numbers and we have to write 3 rational numbers in between those 2 numbers. We will solve this question. See, question number 4, first sub question. They have given us 2 numbers. We have to write 3 rational numbers in between these 2 numbers. There are 2 methods for solving this example. We will see the method first. Whatever the method you will like, you can solve by that. Okay. 0.3 is what? 0.30, and similarly 0.5 is what? 0.50. We know that 0.30 is greater than 0.29, okay, is greater than 0.10, is greater than minus 0.10, is greater than minus 0.30, and it is greater than minus 0.50. Okay, I have already told you that on the number line, as we go to the right side, the number line will be, value of the numbers will be increased, and when we will go towards the left side, the value of numbers will be decreased. So, three rational numbers between 0.3 and 0.5 are minus 0.3, minus 0.1 and minus 0.1. So, three rational numbers in between 0.3 and 0.5 are minus 0.3, minus 0.1 and 0.1. Okay, this is the first method. We have alternate method to find the numbers. So, the alternate method is, see, rational numbers in between a and b are a plus b upon 2. Okay, this is the formula. So, what the rational numbers are? 0.3 and minus 0.5. So, a is 0.3 plus b is minus 0.5 upon 2. See, minus plus get minus and sign of bigger number. So, 0.5 minus 0.3 is 0.2 and sign of bigger number, and here is upon 2. So, minus 0.2 upon 2 is minus 0.1. This is the first rational number between 0.3 and 0.5 is minus 0.1. Now, we get minus 0.1. So, 0.3 plus minus 0.1 upon 2 is equal to minus plus get minus, and 0.3 minus 0.1 is 0.2. So, 0.2 upon the sign of bigger number, that is positive. So, we have got like 0.2 upon 2, 0.2 upon 2 is 0.1. This is the second number, and third number 0.1 which we have found, and minus 0.5 upon 2. If we see here 0. And this minus get plus, and then 0.5 plus 0.1 is 6.6 upon 2 is minus 0.3. This is how we have got the three rational numbers between 0.3 and 0.5 are minus 0.1, 0.1 and minus 0.3. If you want this example, you can take screenshot. We will solve the next one. See question number 4, sub question second. We have to find three rational numbers between the two numbers given. You can use both the methods. I have told you both methods. Now I will tell you just the answers. Minus 0.3 you can write it as minus 0.300, and minus 0.33 you can write it as minus 2.330. Okay, we know that minus 0.300 is less than minus 0.301 and is less than minus 0.3010 and so on, minus 2.3020 and minus here is 3 and 10 and minus 330. Therefore, we can write the three rational numbers as 310, 320 and 330. Okay, 30 or 25. See the next one, the third example, 0.2 and 5.2 and 5.3. We will solve it same like the before. You can use any of the method you want. 5.2 we can write as 5.20 and 5.3 we can write it as 5.30. Therefore, three rational numbers in between 5.2 and 5.3 are 5.21, 5.22 and 5.23. Okay. After that, see fourth question. This is the last question of your practice set 2.2. Minus 4.5 and minus 4.6. Minus 4.5 is what? Minus 4.50 and minus 4.6 is what? Minus 4.60. I have written these three rational numbers between minus 4.5 and minus 4.6 are minus 4.51, minus 4.52 and minus 4.55. Okay, these are three rational numbers in between the numbers 4.5 and 4.6. Today we have completed the practice set 2.2. Question number 2 is remaining because we have to show the numbers root 10 and root 4 I guess on a number line. Therefore we will solve this question in notebook because we have to draw the arc for this. Now I have solved all the practice set 2.2 of real numbers. You have to take down all the solution of the questions in your notebook, and then we will start in next lecture the theoretical part of real numbers. Keep studying, stay home, stay safe, take care of yourself. Thank you.